Welcome to Introduction to Physics Labs. My name is Paul Eric, and today we're going to be doing Lab 1.6a, which is entitled Linear Momentum. So the purpose of today's lab is to define exactly what is linear momentum and what do we mean by conservation of linear momentum. And then we're going to explore objects that explode, and by using conservation of linear momentum, we're going to figure out what do the pieces do. And then we're going to do two objects that are colliding and then sticking together. And then we're going to do two objects that are going to be colliding and then bouncing off of each other. And we're going to be analyzing all of this in terms of linear momentum. So part one is linear momentum and conservation of linear momentum. So exactly what do we mean by linear momentum? Now so far we have discussed things that are going sideways, so they're moving in a straight line, so linear. And so this is the kind of momentum associated with objects that are moving in a straight line. Later we'll talk about angular momentum, where this is going to be the momentum associated with something that is moving around and around. So we have a special letter to represent linear momentum, and it's going to be the letter P, lowercase letter P, and it's defined to be equal to the mass of an object and then multiplied by its velocity. And so therefore the units for this, mass is going to be in kilograms, and then speed is going to be in meters per second. So therefore the unit for linear momentum is kilograms meters per second. So it doesn't have a special unit like the Newton. So we just say that it's that. Now notice that if an object doesn't have any mass, but all objects do, but let's say that it didn't have any mass, what would its momentum be? So 0 times anything is going to be 0. So objects do have mass though. But what about if an object was sitting still? If an object's sitting still, what's its velocity? 0. And so 0 times anything is going to be 0. So the momentum of an object that's not moving is going to be 0. Also, this should be a review. What is acceleration? So acceleration is going to be given by the letter A, and that is the change in your speed over time. And we already know that this has units of meters per second squared. That would be the official metric unit for that. And then from last time, you should know about Newton's second law of motion. So Newton's second law says that force causes a mass to accelerate. But this was not the way that Sir Isaac Newton originally wrote the formula. So what he did was he knew that acceleration was this thing here. So therefore it's going to be equal to mass and then the change in velocity over time. Okay, then you should know something about algebra, so that, for example, let's put it up here. If you've got x times y, that's the same thing as y times x. So what we can do is take this m and put it over here. So we're going to put it right there. So then this is going to be equal to the change in mv and then over t. But we know that mv is momentum, so therefore this thing comes out to be the change in momentum with time is going to be the force. So another way we could say forces cause masses to accelerate, but forces change the momentum of a system. So there's a derivation for you, and it's going to be really important because now we want to know what's going to happen if there is no force. So a force will change the momentum of a system, but the question is, what if there was no force? So that would mean that this side of the equation would be 0. And now 0 times t is still 0. So now we've got that 0 is equal to the change in the momentum, but the change in momentum is the final momentum minus the initial momentum. So that means we could take one of those p's to the other side of the equation, and we would end up with that final result there, that the initial momentum of a system has to equal the final momentum of a system if there's no outside force acting on the system. And so we're going to call this conservation of linear momentum. Very important. So we're going to be making use of equation 1.6a3 for the next 3 parts of the lab. All right, so let's take a break, and when we come back, we will discuss conservation of linear momentum during an explosion.